One of the more interesting ways that trigonometry can be used is for what's called indirect measurements. And we'll see an example of that when we look at how to find the distance between two towns in this example problem. So I'll show you one solution here on the left, and then later on I'll get you to try one on paper, and I'll post the solution here when you're ready. So let's have a look at our problem. 3 roads join hometown, my town, and our town. What is the distance from hometown to our town? And luckily they've included a diagram of the 3 towns, hometown, my town, and our town. Let's have a look at what they've given us in the diagram. They've told us the distance from hometown to my town is 3.9 kilometers, and the distance from our town to my town is 4.5 kilometers. And the angle between hometown and our town is 62 degrees. But what we don't know is the direct distance if you were to walk or drive from hometown to our town. So we need to use trigonometry to find this distance. Now, in case you're asking yourself the very good question, well, why doesn't somebody just drive or walk this distance and record how far it is? Well, what if I were to do this? What if there was a pond or a lake in the way? Now how are you supposed to drive from hometown to our town? So this is an example of using an indirect measurement to find the distance across something. Now that we've settled that, before I can jump in and just start solving this problem, I need to figure out which one of my 3 trigonometry tools works best. I have SOHCAHTOA, or those trigonometry ratios, the sine law, and the cosine law. I'm not going to use SOHCAHTOA, or the trig ratios, in this question because it's not a 90-degree triangle, and those work best for 90-degree triangles. I'm thinking the cosine law, and that's just because I have what's called a contained angle. That is, an angle sort of sandwiched between 2 side lengths that are known. And that's a perfect setup for the cosine law. It really likes to work with contained angles. So that's what we'll do. In order to use the cosine law, though, I'm going to have to label this diagram. So that's step 1. I know the cosine law uses all 3 side lengths in the equation, so I'm going to label M for my town, H for hometown, and O for our town, just to keep things nice and organized. Hometown is right here, so the matching side would be over here, so I'm going to label that with an H. Same for our town. Its angle is right here, so the matching side is over here at 3.9, so I'm going to label that O. And finally, where the water is, we're going to call that M for my town. Now we can start setting up our cosine law. Since I'm solving for the distance between hometown and our town, or in other words, side M, I'm going to write out the cosine law like this. M squared, which is the side I'm looking for, is equal to the other side squared, H squared plus O squared minus 2 times H times O times the cos of the angle that's given, which is 62. And now we'll just fill in the known values. I don't know M, that's what I'm looking for. However, I do know the rest. So H is given as 4.5, and that's squared, plus O, which is 3.9 squared, minus 2 times both of those side lengths. And finally, times the cos of the angle given, which is 62. And there, I've just set up my cosine law. Next, I'll just continue. I'll say M squared, and it's equal to. The rest of this I can punch directly into my calculator. So let's go ahead and do that now. I'll bring up my scientific calculator, and I'm going to punch in exactly what I see there. 4.5 squared plus 3.9 squared minus 2 times 4.5 times 3.9 times the cosine of the angle, which is 62. And if I hit enter, I get an answer of 18.98. I'm going to round that to 19 for this question. M squared is equal to 19. Now we're not quite done because nobody cares what M squared is. They want to know what M is. And since M is being squared, I'll do the opposite, which is take the square root. So I need the square root of 19. m is equal to, and then I'll bring in my calculator to perform that operation. I'm looking for the square root button, 19, and hit enter. And I'm going to say 4.4. That should be good. 1 decimal place, since the other side lengths are given to 1 decimal place as well. So 4.4, and our units for this question are kilometers. And there we go. We found the distance between hometown and our town using the cosine law. Let's add a concluding statement. Finally, my concluding statement says, therefore, the distance from hometown to our town is 4.4 kilometers. And now it's your turn to try. Let's see if you can find the distance between two towns using indirect measurement, just like I showed you on the left. So here's your practice problem. 3 roads join Smallville, Springfield, and Shelbyville. What is the distance from Smallville to Shelbyville? And here is your diagram. So remember, you're looking for the distance between these two towns. Okay, try that one now. All right, how did you make out? It turns out the distance between Smallville and Shelbyville is about 4.6 kilometers. And our steps were, the first thing we needed to do was label all 3 sides, so we had variables to use in our cosine law. You might have used variables that look a bit different, and that's fine, just as long as you were consistent when you wrote out the cosine law, as we did here. Then we filled in our known values. We entered all of this into our calculator to arrive at 21, took the square root of 21 to arrive at our final answer of 4.6 kilometers.